Welcome at KV2 Audio and SLA, Super Live Audio Technology. My name is Stefano Trevisan, and with me is George Campera, co-founder and head of R&D at KV2 Audio. The topic of the next video is problems in audibility. George, can you tell us about audibility?
It's today, basically, everybody talks about this audible, what is not audible. No? And really, first thing, everybody's saying the measure the distortion, no? Which is distracting, no? But the way we measure distortion today, we measure harmonic distortion, which is not as bad, no, as the total distortion, no? And total distortion, no, includes the harmonic distortion and loss of information, no? And because when you measure harmonic distortion, it's easy. You just measure whatever, it's not distracting. You have you can hear like a second harmonic distortion up to 1%, it's not audible. No, same thing at third harmonic 0.1%, it's basically not audible. No, but you have a system which has a very, very low harmonic distortion and still doesn't sound correct. How come? No. That means there is only one explanation to it. There is a big loss of information, which is more audible, no, than harmonic distortion. No, correctly measure distortion, and how we measure distortion, it's actually you have a amplifier, no, and we have a summing point. We get an output from the amplifier and input, no. And we subtract that signal. Now, the difference between those two signals, now it's a distortion. This is only way how we can measure total distortion. We are not talking about THD, total harmonic distortion. We're talking about total distortion. No? And that gives us a real information about the distortion. If people will apply that kind of system to measure distortion, they will be really surprised how bad are things like CDs and everybody's saying like a CD 44 kilohertz, it's up to 20 kilohertz bandwidth. You cannot hear the difference. No, it's over our listening range. No?
Which kinds of distortions are included in the total distortion? If we're talking about total harmonic,
it's a loss of information, truly. In analog, no, amplifiers, it's a problem with the settling time. It's a time when the takes time before the signal which come in, no, and the signals come out refer to the signal on input. That time it's called a settling time, but at that time, no, we're getting wrong output, no. And that will add to the distortion, not harmonic. It's a loss of information. Same problem we have it on digital part, no? And there is basically a problem with the sampling rate, no? Because as you have a samples, whatever it's between, it's lost, no? It's very interesting if you measure a digital system this way, no? The distortion is huge, no? It's a very good example. You can put 10 kilohertz in the CD, in the 10 kilohertz square wave, which is approximately over 30% distortion, but you measure 0, 0, 0, nothing on the output.
Yeah.
They just filter out, but the distortion is still there, no? Some people are saying it's 44 kilohertz, it's enough, you don't need more. Why are we increasing the sampling rate? Why are we going up to 384? Because when you switch from 384 to 192, first thing which you hear, increase of distortion. No, if you go from even lower to 96, again, that step, no, compression, you're gonna hear the distortion. It's not like you're losing the bandwidth or whatever. You hear more distortion, no? And for that reason, basically, we move. That's why we came up with the SLA standard, no, when we move the digital very high, no, and same thing make the analog part very fast. And that way we reduce dramatically the distortion. That's where the sound comes from, so clear, so open. Of course, you're gonna hear whatever you put in. If you put MP3 in, no, you're gonna get MP3 out. If you're gonna put live violin, when it's mic, preamp, and go directly to the system, no, you will be surprised at what you're gonna get. Superior sound quality. No, it's real. And basically that's the major problem. Then, of course, as you have to deliver the signal, when you are 1 meter from the source, the losses in the air are relatively low. No, but as you go further, no, you start losing again information, no, about the sound, no, and it means in long distance, no, you're gonna have difficulties to understand what they say, no, to listen to music. And it's, at that point, it's very important, on the beginning, have a highest possible quality, because that represents how far you can shoot.
Yeah. You were talking shortly about the signal path, like taking a violin with a microphone, going through the signal path. What can you say about the components of KV2 audio? Because we were talking about that 1 microsecond that is
everything is under that rule.
Everything, so the whole signal path
Yes.
in KV2 is
Yeah.
under 1 microsecond.
Yeah.
And can you say which are the biggest bottlenecks in the signal path in modern sound systems, and why we have that lack of information?
I would like to point out one thing. In recording today, in digital recording, one advantage of that, we have time for processing. In live situation, we don't have a time for processing. And that's the difference in quality between recording, digital recording, and reproducing using digital in the real time. No, because you cannot have a delay in real time. You know, now if you push the button and the computer start playing half second later, nobody can tell. Yep. Try to do it in the concert. No, it's impossible. And therefore, the system as it's working, it's way too slow. That's the problem for the digital in live situation. The best way, it's if you want to A/B, you have to A/B those two systems. Put in highest possible quality source, and that the difference, you can hear the difference between one system or other. I never bought the car without trying it. No, and I strongly believe if you want to buy the sound system, you should check it out before you do it. I just ask for competition. Just put the systems beside each other, and then you decide for yourself. No, and you can decide for the features. Then the sound is not important, or you go for the sound. That's your decision.
Okay, thank you, George. I hope you enjoyed this video. Thank you very much for watching, and see you soon.